Hello students, let us start solving exercise 11b. First numerical. 10 gram of ice at 0 degree Celsius, ice at 0 degree Celsius absorbs 5460 joule of heat energy to melt. So first ice melts into water. Now when state changes, okay, here ice is changing into water, state changes, temperature does not change. So whatever heat energy is absorbed during this change in the state, that energy can be calculated using the formula ml and not mc delta t. Ice melts and changes to water at 50 degrees Celsius. So temperature of this water increases up to 50 degree Celsius. So what is the temperature change? 0 to 50, 50 degrees Celsius. For that process, heat energy absorbed is mc delta t. So in the question it is given that ml plus mc delta t, that value is 5460 joules. So from this information, from this formula, we can find out what is the specific latent heat of fusion of ice, that is L. Mass 10 gram into L plus mass 10 gram into specific heat capacity of water 4.2. See, the specific heat capacity of water is given 4200 joule per kg Kelvin. But since mass is given in gram, the value of C in the formula we must take in joule per gram. So 42 upon 10 into delta T is 50. So we can cancel one zeros from both the sides. So 546 is equal to L plus 42 into 5 is 210. So L is equal to 546 minus 210, that is 336. So L is 336 joule per gram. That is the specific latent heat of fusion of ice. Second numerical. How much heat energy is released when 5 gram of water at 20 changes into ice at 0 degree Celsius? So initial temperature of water is 20 degree Celsius. That finally changes into ice at 0 degree Celsius. But first the temperature of water will decrease from 20 to 0 degree Celsius. During this process, heat released can be calculated using the formula mc delta t, and now the temperature of water is 0 degree Celsius. Okay, so now water will turn into ice at 0 degree Celsius and heat energy released for that process is ml. So what is mc delta t plus ml? That is the question here. How much is the total heat energy here? That is given out for this process. So we can take mass common, that is 5 gram. Specific heat capacity of water is 4.2. So 42 upon 10 into what is temperature change? Temperature change is 20. So 20 plus specific latent heat of ice is 336. So 5 into 84 plus 336, that is 5 into 420 into 5, and that is 2100 joule. Third numerical, a molten metal of mass 150 gram, molten metal of mass 150 gram is kept at its melting point 800 degrees Celsius. 800 degrees Celsius is the initial temperature of molten metal. When it is allowed to freeze at the same temperature, so it freezes into solid metal at the same temperature. Now since temperature does not change, how much is the heat energy released? ml. And that information, that value is given to us 75,000 joule. What is the specific latent heat of metal? So we can use this ml is equal to 75,000 to calculate L. L is equal to 75,000 upon mass is 150. So that answer is 500 joule per gram. Okay. Now it is given further in the question that if specific heat capacity of metal is 200 joule per kg Kelvin, how much additional heat energy will the metal give out in cooling to minus 50 degrees Celsius? So solid metal cools down up to minus 50 degree Celsius from 800 to minus 50. What is delta T? It is not 750. Delta T is 850. First 800 to 0 and then 0 to minus 50. So total temperature change is 850 degree Celsius. Be careful here. So heat energy given out for that process is mc delta T. So Q is equal to mc delta T, mass 150 gram, specific heat capacity is 200 joule per kilogram. That must be converted into joule per gram. Okay. So divide 200 by 1000 into delta T is 850. So this is 300 into 85 and that is 25500 joule. This much is the additional heat energy released. Fourth, a refrigerator converts 100 gram of water at 20 to ice at minus 10 degrees Celsius in 73.5 minutes. Calculate the average rate of heat extraction in watt. So basically we are asked to find out power, that is Q upon T. The specific heat capacity of water is given, specific latent heat of ice is given and specific heat capacity of ice is also given. So here refrigerator converts 100 gram water. How much water? 100 gram at 20 degrees Celsius to ice at minus 10 degrees Celsius. So does water convert into ice at minus 10 degrees Celsius directly? No. First, the temperature of water will drop, decrease up to 0 degrees Celsius. Then the state changes, water freezes into ice at 0 degrees Celsius. And then the temperature of this ice decreases up to minus 10 degrees Celsius. So water at 20 to water at 0, delta T 20 degrees Celsius, heat energy released mc delta T, but this time here we write Cw, right, because we are talking about the temperature change of water. Then the temperature, then water freezes into ice, so change in the state ml, and then the temperature of ice drops from 0 to minus 10 degrees Celsius. So heat energy released is mc delta T, but this time it is for ice. So mci delta T. Ci stands for specific heat capacity of ice. So when I add mcw delta T, ml and mci delta T, that is the value of our Q. Divide by time to find out the power. That's the formula that we can frame here. Okay. This is the equation, right? So now power is equal to, I can take m common from all the steps in the numerator. Mass is 100 gram, so that calculation becomes little easy. Specific heat capacity of water is 4.2, 42 upon 10. Delta T is 20 plus specific latent heat of ice 336 plus Ci is 2.1, 21 upon 10 into temperature difference for ice is 10. And this entire process is completed in 73.5 minutes, which must be converted into seconds. So now 1010 gets cancelled, here also 00 gets cancelled, and we get power is equal to 100 into 84 plus 336 plus 21 upon 735 into 6. So when we simplify, okay, now use your mathematical skill to find out to simplify this, and you will find that the answer is 40 watt. Fifth numerical. In an experiment, 17 gram of ice is used to bring down the temperature of 40 gram of water at 34 to freezing temperature. What is the freezing temperature of water? 0 degrees Celsius. Right? Freezing temperature of water or melting point of ice is the same. Specific heat capacity of water is given. Calculate the specific latent heat of ice. State one important assumption made in the above calculation. Okay. So here 17 gram of ice is used to bring down the temperature of 40 gram of water at 34 degrees Celsius. So here what is given to us? Ice is given how much? 17 gram. That is mixed with water. How much water? 40 gram water. At what temperature? 34 degrees Celsius. What is the initial temperature of ice? Not mentioned here in the question. So by default we take 0 degree Celsius. Okay. These two are mixed. Now the moment these two are mixed, what we are doing, we are generating temperature difference, and due to which the heat transfer takes place. Heat transfer begins from hot substance to cold substance, and this process we know continues till both are at the same final temperature. What is the final temperature? 0 degrees Celsius. How can we say that? Read the question again. In an experiment, 17 gram of ice is used to bring down the temperature of 40 gram of water at 34 to its freezing temperature. Meaning, final temperature of water is 0 degree Celsius. Okay. So, final temperature of this entire mixture is 0 degree Celsius. The specific heat capacity of water is given, and we have to find out specific latent heat of ice. So now see, ice at 0 degree Celsius is the cold substance, okay, that absorbs heat energy from hot water. So what will happen to this ice? This ice will convert into water. Temperature does not change, so temperature remains 0 degree Celsius. This heat energy absorbed is ml. But from where heat energy absorbed, heat absorbed is equal to ml. But from where it comes? It comes from heat. It comes from heat released. Heat released. So what is the heat energy released? Heat energy is released by water at 34 degree Celsius. So temperature of this water decreases from 34 to 0 degree Celsius. Okay, and this heat energy released is mc delta T. So this heat energy absorbed ml and heat energy released mc delta T are equal. What is the assumption? The assumption here we are making is that no heat is lost to the surrounding. Remember one more thing, that ultimately, finally, if you see the mixture, the final end product is only water. Okay, end product is only water at 0 degree Celsius. Alright, so now since we know ml is equal to mc delta T, remember these two masses are different. Okay, the mass on the left side is mass of ice and the mass on the right side is the mass of hot water at 34 degree Celsius. So this is 17 gram. L we want to find out. Mass of hot water is given 40 gram. Specific heat capacity is 4.2. And delta T. What is delta T? Delta T is 34. So this is 8 into 42, and that is nothing but 336 joule per gram. Okay, so specific latent heat of ice is 336 joule per gram. Sixth numerical. Find the result of mixing 10 gram of ice at minus 10 degrees Celsius with 10 gram of water at 10 degrees Celsius. Now find the result of mixing. Whenever this type of numerical comes, okay, and if this is the word in the numerical, result of mixing, that means we have to find out how much ice melts. That is what we want to figure out. How much ice is given here? 10 gram ice is given. So when this 10 gram ice at minus 10 degrees Celsius is mixed with water at 10 degrees Celsius, will all ice melt? No, only certain quantity of ice melts. Okay, so how much ice melts? That is what we want to find out. So let me first prove it. Okay, let me first prove my point here that all ice does not melt. Let us say all ice melts. So how much heat energy will it absorb? When all ice melts, heat energy absorbed is mass times L. mass is 10 gram, and specific latent heat is 336. So this is 3360 joule. Okay, so this much energy is required for ice to melt. Also, initial temperature of ice is not 0 degrees Celsius, it is minus 10 degrees Celsius. So first of all, the temperature of ice will increase from minus 10 to 0, and for that heat energy required is mc delta T. Okay, mass is 10 gram, specific heat capacity of ice is 2.1, and delta T is 10 degrees Celsius, minus 10 to 0. 10 gets cancelled, and what we get is 210 joule. So when I add these two, I get the answer. Total answer of this Q is 3360 plus 210. That is 0, 6 plus 1, 7, 3 plus 2, 5. 3570 joule is required. For what? For ice at minus 10 to ice at 0, and then ice at 0 to water at 0. So for this particular process, this much heat energy is required. Now this heat energy must come from hot water at 10 degrees Celsius. Let us see that water quantity which is given here. Is it able to release this much heat energy? Let us find out. So water at 10 degrees Celsius, the temperature decreases to 0 degrees Celsius. Okay, heat energy released is mc delta T, and this heat energy is mc delta T is equal to mass 10 gram, specific heat capacity is 4.2, and temperature difference is 10, so it is 420 joules only. Whereas the heat energy required to convert ice at minus 10 to water at 0 degrees Celsius is 3570 joule. Whereas water at 10 degrees Celsius is capable to release only 420 joule energy, and the temperature decreases by 10 degrees Celsius. Okay, so of course, by absorption of this much heat energy, all ice does not melt, only certain quantity melts. So 420 joule heat energy is absorbed by ice at minus 10 degrees Celsius. So ice which is at minus 10 degrees Celsius first will absorb 210 joule energy to increase the temperature up to 0 degrees Celsius, and then ice will convert into water at 0 degrees Celsius. But see, out of 420, 210 energy is already used to convert to change the temperature of ice from minus 10 to 0. That means now remaining only 210 joule energy is left to change the state of ice. Okay, so that is m into L. So this m is equal to 210 upon L is 336. That is only 0.625 gram. So only 0.625 gram ice melts. And what is the final temperature of the mixture? Of course, 0 degree Celsius.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.